Hello everyone, this is 𝐂𝐻𝐨𝐬𝐢𝐭, Embedded System Engineer at Varsity. This video is for ECE, EEEE pursuing students, graduates and working professionals. We build a project togetherly on smart attendance system using RFID card. So in this video, today we are going to cover what is RFID card and working principle of the RFID card, coding part, and end with the live demo. So let me ask you, how usually attendance taken in your colleges or offices? It is a manual, slow to manipulate, and maybe even some making attendance for a friend. We all know a traditional system are time consuming, error prone, and proxy attendance system. That's where technology step in. Now let's start the project. Now I'm going to explain you the concept of RFID card. RFID card is a card. It is a radio frequency identifier. Usually it sends a radio signal. So it is RFID reader RC522, and this is RFID card. So when RFID reader and a card both will come contact to each other, then the electromagnetic waves will be generated. Usually it's act like a transmitter and receiver. So when you are transmitting a signal, then when receiver both will come contact to each other, then from one device to other device it will transmit the data, then using electromagnetic waves. This usually used in RFID cards. So once the signal is been received, then that signal will send to the microcontroller. Here I am using ESP32 is a microcontroller which supports Bluetooth and Wi-Fi module. So using this microcontroller, I am storing all the codes. So usually in this project, I am going to build three parameters. One is for registration mode, and another one is for lunch mode, and one is for attendance mode. So this all concept we need to be covered. So now we are going to build a project togetherly. So before going to build any projects, but we need to think three things in our mind. First is hardware implementation. Second one is code debugging. Third one is model preparation. So now we start with the hardware implementation. So for that we need a proper connections. Connection is like that. This is a connection diagram, how you can connect this end-to-end product, like all the sensors, how you can going to be connect with the ESP32. So starting from RFID to the ESP32 connection. So here is the connection diagram. First RFID pin SDA will going to be connect GPIO 5. Similarly SCK will be going to be connect GPIO 18. MOSI will be going to connect GPIO 23 of the ESP32. MISO will be going to connect GPIO 19. Reset button will be going to connect GPIO 4, and ground will be going to connect ground of the ESP32. VCC will be going to connect 3.3 volt of the ESP32. Here you need to ensure that only you need to connect RFID to the 3.3 volt only. If you are connect 5 volt, then might be chances are there RFID reader get burned. Okay, now this is the connection diagram of LCD with liquid crystal 16x2 with I2C model. So here this all work on I2C protocol, integrated circuit. So SDA of LCD pin will be going to connect GPIO 21, and SCL pin going to be connect GPIO 22 of ESP32. Similarly, VCC will be going to connect 5 volt of the ground, 5 volt of the ESP32, and ground will be going to connect ground of the ESP32. Here you need to take a common ground connection from the ESP32 to any breadboard, and VCC you need to take a common 5 volt for the breadboard. Now here is the connection diagram of button pin. So I inserted button for the three stage. First one is registration mode, second one is attendance mode, and third one is lunch mode. So switch mode, we need a button. So one end of the button will be going to connect GPIO 15 of the ESP32, and other end of the button will be going to connect ground. Similarly here buzzer and LED.
So buzzer is for indication to the user that your attendance is been marked. So positive terminal of the buzzer pin is going to be connect GPIO 26, and negative terminal of the buzzer pin going to be connect negative of the ground of the ESP32. Similarly, LED will be going to connect anode. Anode is nothing but a positive terminal. So positive terminal is going to be connect a GPIO 32. Negative cathode. Cathode will be going to connect ground of the ESP32. Here, if possible, you can add any resistor. This is the all connection diagram of the hardware implementation. So now hardware implementation is been done once you make the proper connection. So now we'll begin with the code. For code implementation, we need to make a proper Google Sheet before going to code. Here, Google Apps, Sheets. When you click on the sheet, then take a blank spreadsheet. Here, untitled spreadsheet. Here you need to give the sheet name ESP32. ESP32 underscore smart attendance system. Smart attendance. Once your sheet is been name is been given, then click on the extension app script. In the app script, we need to write a Java code. For that, I written on already JavaScript. So this JavaScript link I will be given to the description. So this entire JavaScript code you need to copy and paste it in app script control A. Once you paste all the code in the app script, then go for the deployment. Here, before deployment, ensure your sheet ID is to be mentioned. Sheet ID is nothing but just go to the sheet. Here, whatever you are seeing after D, this all is your sheet ID until edit. So you need to copy this sheet ID, then go to app script. Here you need to replace. Once you replace the sheet ID, then go for the deployment. New deployment, web app. Here just ensure that it is visible to the anyone and deploy. It takes some time. Then click on authorization, click on Google email, then click on advanced, untitled projects. Similarly, here you need to give the permissions. Click on allow. As soon as you give the permission, then it takes one give the one URL. This is URL and this is deployment ID. So this URL you need to copy and paste it in the Arduino IDE code. Done. Here this is Arduino IDE code. So here you need to paste the web URL, whichever we copied from the Google Sheet. Then again go to the Google Sheet. Here sheet 1, give a name, registration, ensure whatever name you are giving here, it should be matched to the app script. Like here user data I given, sheet 1 user data. So you also give the same name to here. username, here name and UID, name and UID. This sheet is for the registration of the new user. Now add a sheet. In the second sheet, you need to make a proper attendance sheet. Here you need to maintain the proper attendance like a name and UID number and date, time in, time out. So again, similarly, second sheet, rename it as attendance. Ensure whatever you are written in the script, you need to rename accordingly. Attendance, here name, UID, date, time in, time out. Once your Google Sheet is been ready, again one more sheet we need to add for a lunch mode. Rename it as a lunch mode. So here we are storing the data of those who are went to the lunch. Name, UID, date. Here timeout will come first and time in. Once your Google Sheet is been ready with all the data, now you need to just deploy this Arduino IDE code to the ESP32. Before going to deployment, first you need to ensure that whatever the library is been added here, you have to install this all the library from libraries. This MFRC5222, this is the library for the RFID. See, this all library you need to install. This is the liquid crystal I2C library, SPI library, and this is Wi-Fi.h HTTP client library. So as soon as once your library is been added from the library section, then here ensure that SSID and password you need to replace. So password is nothing but your Wi-Fi password, SSID is your Wi-Fi name. So SSID is your Wi-Fi name, you have to replace it here, and password is nothing but whatever the password you are assigned to it. Okay, here is web URL. Web URL we copied from the deployment of Google Sheet. This is all the total how entire project is been work. This is 16x2 LCD address. It has the 16 columns and 2 rows. Similarly, here we write the logic for the buzzer. When buzzer should be turned on, when buzzer should be turned on. Here I return HTTP request. It send an HTTP request to the client stating that you have to give one response. So here it it is for the lunch mode. Again, once the lunch mode is been done, it shows that entire data will be stored. After in LCD, we need to print for attendance done for a day. If multiple users are scanning same attendance scanner in the same day, then it shows attendance done for a day. Here error is not registered. If you tap any invalid card, then it print error not registered, tap the valid card. Similarly, here whatever you are seeing, if registration is successful, then UID registration successful, it will display on the LED. Similarly, this all code you need to dump. Here in the white setup, we need to declare the pin which is the input and what is the output. So here buzzer pin low. So this all logics you need to write it here. So all this code I given in the description link. Just select the board tools and board. Here ESP32 will come, and once you select the board, just upload the code. Once you upload the code, then start for the demonstration. So now I will show you the demonstration.
So now this is our smart attendance system. So this all are the components are being utilized to develop a project. So this is an ESP32 microcontroller. So ESP32 microcontroller is a controller which supports inbuilt Bluetooth and Wi-Fi. So it stored a 32-bit microcontroller, and it stored the programming, whatever the program we write in the Arduino IDE. So that all program is being stored in ESP32 microcontroller. Similarly, this is an RFID reader RC5222. So this RFID card is used for to send a data to receive the signal from the reader. So similarly, this is an LED and a buzzer. So LED and buzzer I use for indication to the user, stating that your attendance is being marked. Similarly, this is a push button. So push button is used for to toggle the states. Like I am using 3 states. First is your registration mode. Second is your attendance mode. Third one is your lunch mode. Similarly, so when I press on the push button, that time your state will be changes from one stage to another state. So this all data will be displayed on liquid crystal I2C with I2C model. So like registration mode and attendance mode, so all data will be displayed on liquid crystal 16x2 display. So this is a power code system. Okay, we need to give the power with the help of adapter. Only 5 volt it is going to be take. Similarly, this entire thing I built using a PCB board. So PCB board, I integrated all the components on a PCB board on top of the board, and backside I make the connections. So now we'll begin with a live demonstration. After completion of hardware implementation, code debugging, now we'll start with a demonstration. So demonstration, first you need to turn on the power. As soon as power is been turned on, then it shows ESP32 RFID attendance, connecting Wi-Fi connected. Then first is showing attendance, tap your card. For that, first you need to do the registration of the card. So for that, you need to switch the mode from attendance to the register. So in the registration mode, when you come to the registration mode, then your RFID card will take nearer to the reader. So when you take nearer to the reader, similarly here it should be UID number will be print, followed by LED and one beep sound. And after registration is been successful, same UID number will be coming in your Google Sheet. Here you need to just give a name like username. This is for one card. Similarly, this is for card number 2. Again, takes an UID, name in the Google Sheet. This is card number 3.
I am sure it's
Card number 3 also printed. Once the registration has been successful, then go for a registration mode. In the attendance mode, again switch your sheet to the attendance. Here again name, UID, date, time in, time out will be print. Similarly, those which all are the register reader card, you need to take again, go nearer to the reader, getting UID details. It will print here name Varun and UID, date, time in. Similarly, when you scan the same card on the same day, again it will take as a timeout. This is a logic which is written in the JavaScript. Similarly, card 2, it print the LCD display values. This is for card 2. Again, in the same date, when you scan same card, it will take a timeout. Now attendance mode is been completed. Go for the lunch mode. In lunch mode, again you need to switch your sheet to the lunch. Here button, from attendance to lunch mode you need to switch. Like this. Again same card. Getting UID details. In the Google Sheet, it should print name, UID, date. Here timeout will come. Again, this is for second card. Just observe the LED and buzzer.
Right.
When data is been read from the RFID reader, it should be again beep for the user, stating that your registration or attendance or lunch mode is been completed. Similarly for timing also. When you scan the same card on the same date. Now let us assume if a card is not registered, even though user is scanning, it should print error. It is not a valid card. Please tap a valid card. So for that, again you need to switch from a lunch mode to the registration mode. Again scan a new card. UID number will be print. Switch your sheet to the user data. Here again give a name. Then again you can switch either attendance mode or lunch mode. Now here in the attendance mode, what if already I scanned all the like here name, these two names are already completed their attendance, time in, time out. Even though now I will scan the card, it should print attendance done for today, like this. So this is all the concept. Again, even though in lunch mode also it should print same. So this is all the concept of the smart attendance system with an RFID card. We turn a routine task into smart with automated solution. We did this project using ESP32, RFID card, Google integration. I hope you all enjoy this project. In the below description, I attached the PDF which contains a source code and connection diagram. Stay tuned for more embedded projects with Cranes Varsity and hit like and subscribe. Thank you for watching.